Hello everyone, good evening. Welcome to PyNet Labs. So this is our webinar on designing and deploying the redistribution in enterprise networks. So here in this webinar today, this webinar is going to be it's more about the IGPs and some BGP protocol also we have included in this webinar. So this is going to be very interesting. So guys, let me introduce myself. My name is Jatin and I'm a corporate trainer and I'm associated with PyNet Labs. And I have been delivering trainings on CCNA, CCNP, and core and NRC as well to corporate clients and as well as to participants for our JGP programs. So I am going to take this webinar, and in this webinar, as we have already discussed, that we are going to cover up the redistribution part. So we are going to start with the redistribution, like what exactly redistribution is. So it's just a topic agenda which we are discussing as of now, that what are the topics which we will be covering up. So we will talk about the redistribution here, what exactly this redistribution is. Then once we understood the concept of redistribution, we will try to understand it with an example of, a production environment, like we will connect it, this lab with the real environment, how exactly this redistribution is worked in enterprise networks. Then once we are going to understood this redistribution, then we will move to some configurations where we will redistribute EIGRP and RIP version 2. Then once after doing this EIGRP RIP lab, we will see some redistribution of IGP protocols, and also we will see some EGP protocols. So basically we are going to talk about IGPs, and in correlation with we are going to see with BGP as well, like how exactly we are going to redistribute the routes here. Now coming to the point, we will be starting with this. Basically, just let me show you one image, how exactly this redistribution works. So I have created a topology here. Let me show you my topology. So as you can now see on the screen, that this topology which I have created, just forgot about these three routers. They are not included in the topology. They are for another lab scenario. Now let's have a look at this topology. So we can do one thing. Let's just take a snip and we will try to understand the same topology on our PowerPoint slide. So as you can see that here, for example, if you will see that I have connected some routers. So you can see there are some 6 routers till VIOS 6. Now let's get back to the PowerPoint slide and let's see. So now see guys what exactly this redistribution is. So whenever we are talking about the redistribution, so we can write the point about redistribution as well, that what is exactly this redistribution is referred as. So let's start. So whenever we are talking and describing the redistribution, what exactly this redistribution is. So basically this is a redistribution is a process of exchanging routes between different networks. Now how basically it's done, we will see that. So that is what, like, in simple terms, we can say this is what redistribution is, that it is basically a process where the exchange of routes between different networks, between different routing protocols, like, we will be injecting or ejecting the routes from this redistribution. Like how we will do this. Now you can take this example. So here in this topology, you can now see that we have some pre-constructed topology. So here in this topology, if you will see that in this first block, we have configured some BGP. Let's say this is eBGP. And let's say this is my production environment, where is this is my LAN 1, let's say, and this is my local area network 2. Now let's assume that this is basically some ISP router which is providing connectivity to your LAN network. So over here you can see that there are some AS numbers which I have configured. So it's by AS 100, 200 and 250. So 3 different autonomous systems are there. Now this is something we can say this is your wide area network. Now how exactly, like for example, this is some other branch of your company where you are working, and these are some other operators, or we can say some other branch offices of your organization. So we can simply just make sure that the communication between these different routing protocols should be there, because Here in the second block, if you will be looking at, so we have configured some OSPF. So by default, OSPF cannot communicate with the BGP routes, or even it cannot communicate with the EIGRP routes here, right? So this is what basically in this today's session we are going to have a look on that. So let's try to understand what are the types of routes in this redistribution. So we can write the heading types of routes. Now when I say types of route, what I exactly am referring here is, so we can say there are two types of routes. The first we have is your internal routes, and then we do have is our external routes. Now, when we are talking about the internal and external, how we basically define these routes here in the redistribution. So basically, internal routes are nothing but the routes advertised within the same protocol. So basically, if you are making the communication from one OSPF domain to another OSPF domain, so in that case, you can also make sure that this is something kind of internal routes where we are going to we don't need the redistribution in case of internal routes, because they can easily communicate with each other by using their own mechanism and algorithms, and they're using their own calculation methods. But when it comes to external routes, so these are the routes which get distributed. So we can simply say routes which gets distributed. Now here we will see one example, like what is the prerequisite to understand and doing the redistribution process. So the first thing is you must be having some good knowledge on the routing part. This is the prerequisite before doing the labs. And if you are familiar with the routing part, so you must be familiar with the metrics as well. Like when I mention the metrics, so we can say that we have three types of routing protocols. Like when I talk about the IGP, so we have RIP, we have OSPF, and we have EIGRP. So all these protocols are having their own metrics. Let's say if I'm talking about RIP, so RIP is having some metric of hope. When we talk about the OSPF, so OSPF says that I am having the metric of cost. And when we are defining the EIGRP, so EIGRP is going to have some 5 parameters where bandwidth is there, delay is there, load is there, MTU is there, and reliability is there, right? So these are the metrics which you must be familiar with, and you must be having some good knowledge, and you must be knowing like how exactly these metrics works. So that is just simple prerequisites to perform the redistribution, and it's not that complicated, which it's like, we think that making the communication possible between two different networks is something pretty much complicated. So as per this topology, which we have seen here, what we are going to do is we will be redistributing some routes from BGP to OSPF, OSPF to BGP, and also we have configured some EIGRP. But before moving to this complex topology, we will be looking a very simple topology where I have taken three routers. So just let me show you my lab screen so we can have a look on the lab. So here you can see guys that these are my three routers which I have taken on as of now. So like on this three routers, let's try to understand the EIGRP RIP redistribution. So in this scenario, as you can see, there are three routers. On the gig 00, we have some 1.0 network, and on the other side, we have some 2 dot network, which is a part of EIGRP domain. Now, the first and most important thing doing the configurations. So first of all, let's go and check the configurations of these devices. So we'll be going on the VIOS 7 here. So let's say enable, this is your VIOS 7, and on this VIOS 7 we'll see show IP interface brief. So you can see as of now there is no IP. So let's quickly assign the IP. We have interface gig 00, and then on the gig 00 we have 1.1.1 255.0.0.0 and no shutdown, exit. Now once we have executed the IP, let's say we are gonna create one loopback interface as well on this VIOS 7 to make the communication better. So let's say I have some IP address to give on the loopback is 10.1.1.1 255.0.0, and we'll simply exit. Now basically guys, as you can see that this VIOS 7 and this VIOS 8 gig 0 link are the part of routing information protocol, which is RIP version 2. So we will configure some, let's say RIP here. So we will define router RIP version 2, we'll write no auto summary. And here we have one network which is 10 dot network and another network which is we are having is 1.0.0, right? So now this is the basic configurations which we have done on the VIOS 7. Now if you will be having a look at this VIOS 8 configurations, so here on this VIOS 8, you can see that there are two routing protocols which are connecting with their other routers, like VIOS 7 is a part of RIP and VIOS 9 is a part of your EIGRP. So basically we'll say this router configure terminal. So interface gig00, which is a part of RIP protocol. So we'll advertise the IP first, let's say 1.1.2, and the default subnet will say no shutdown, exit. Then another side we have is gig00. This one is your gig01. So our gig01 we will say 2.2.1 and 255.0.0.0, and we'll simply say no shutdown. Now if you will see, to verify do show IP interface brief you can use. So you can see these are the IP configurations. Now as per these configurations guys, you can now see that the one interface which is my gig00 is basically a part of RIP version 2. So what I will do is I will go with the router 3, sorry, on this middle router, and I will say router RIP version 2 no auto summary, and I will advertise the network 1.0.0, and once done exit. Now I will also do the same for router EIGRP 100, because my gig01 which where we have assigned the IP which is 2.2.1 is basically a part of your EIGRP domain. So we will say router EIGRP 100 and we will say no auto summary, and we'll advertise the network, let's say 2.0.0.0. So once this is done, we'll simply exit and go out of the configurations. Now once this is done, we'll move to the last router, which is your VIOS 8 here. Okay, so there is a misconfiguration error guys between the devices. So what are the configurations which we need to done on this VIOS 9? I have done it on like your VIOS, the configurations of VIOS 8 has been done on your router number 8, sorry. So let's just undo that. No router RIP, no router EIGRP 100, and also we will check the interfaces, do show IP interface brief. So because this is your VIOS 9 here, so let's undo the interfaces as well. Let's say interface gig00 will be having some IP address of 2.2.2 and 255.0.0. Okay, so we'll start it again. Interface gig0/0 and then no IP address, and now we will define the IP address as 2.2.2 255.0.0.0, and let's check show IP interface brief. Okay, so on gig01 also it's 2.1, so that is why it was showing overlap. So let's try to change that. We'll go on the interface gig00, sorry, on the 01, and we'll say no IP address. Now it's done, so we'll write interface gig00 and we'll say IP address 2.2.2.2 and 255.0.0, and we'll say no shutdown, and let's say one more command here. So we can create one loopback IP as well, because I want to show you the roots of EIGRP into the routing information protocol. So here we are in this, so we will write the IP to this loopback as, let's say 30.1.1 255.0.0, and then exit. So once this is done, we'll advertise some EIGRP here, router EIGRP 100, no auto summary, and network I have here is three. Basically I have two networks. The first one I have is 2.0.0, and then the another network I do have is 30.0.0. Exit. Now if you will see show IP interface brief, so you can see on gig00 we have 2.2 and we have one loopback, and we have also advertised the EIGRP here. Now we'll go to the VIOS 8 configurations, like which is your middle router where we did the misconfiguration. So let's try to verify show IP interface brief. So here, as you can see, that on the router 8 we have this gig00 and gig01. So let's assign these IPs. So interface, we have gig00, and IP address we are having is 1.1.2.255.0.0. No shutdown, exit. The another interface I have is gig0/1, and on the gig01 I do have is 2.2.1 255.0.0 and no shutdown, exit. So now as IPs are assigned, you can also verify show IP interface brief via the IPs. That gig00, which is basically the part of RIP version, is having 1.1.2, and this gig01 is having 2.2.2.1. So I'll go with the configurations. Now you will see that when I will do EIGRP configurations here, router EIGRP 100, no auto summary, and I will simply advertise one network, which is my 2.0.0, exit. So you can now see that dual agency has been formed, and the same thing I'm going to do with the router RIP version 2. It's version 2, no auto summary. Then we will advertise the network 1.0.0. So once this configuration part is done, so now if you will see on the VIOS 8, show IP EIGRP neighbor. So in this neighbor, you can see that 2.2.2 is the neighbor. But now when we will be going and checking the routing tables of both the routers, let's say if you are going to see the routing table of your router 2, so you can see show IP root, this VIOS 8 we can say. So you can see here on this VIOS 8, which is the middle router, which is connected to the RIP router and the EIGRP router. So you can see here that this RIP route is there, which is having the AD of 120, and this OSPF route is there, which is having the AD of 90 here. So you can see that this 10 network is connected via 1.1.1, and this D network is connected OSPF 1, which is 30 network connected via 2.2.2. Now, when you are going to verify the routes here, so now if you will go on the VIOS 7 here, and let's verify the VIOS 7 routes. So we'll say show IP route on the VIOS 7. So you can see in this VIOS 7, only local and directly connected routes are there. So basically, now this router VI7 is not advertising any routes of EIGRP here. So what we are going to do is we will redistribute the RIP from EIGRP and EIGRP to RIP here on the router 2, because router 2 will be responsible for redistributing the routes here. So what exactly we need to do is for the redistribution between both of the protocols RIP and EIGRP. So let me also verify you the routing table of this VIOS 9. So here you can see this is VIOS 9, and in this VIOS 9 show IP route, if you will write, so you can see that there is also no redistribution done here, or there are no other routes here. So now if you will see, we will be redistributing the routes. Now the router 8 is responsible for redistributing the routes. So here on this router 8, you can see both of the routes are there, RIP and OSPF, but we need to redistribute these routes. How we will do that? We will simply say router RIP, because like as of now I'm redistributing from RIP from EIGRP. So router RIP, I will say redistribute EIGRP metric, then okay, redistribute EIGRP 100. We are gonna use the autonomous system here, and once the autonomous system is set, then you will write and put question mark. You can see the metric option we got. So once you will write the metric, and then you can see it is asking for the default metric, because we are redistributing RIP, so it is asking for the metric of RIP. So as of now we have only one hop count here, so we will simply write 1. So once this is done, now if you will see the routing table of this VIOS 7, so you will see the 13 network which we created on this VIOS 9. So let's try to verify the VIOS 7. So this was the previous output of your routing table which we verified on this VIOS 7. Now again if you will verify, so you can now see that there is a redistributed route of 30 network coming via 1.1.2. So this is how we are going to redistribute your RIP from EIGRP. Now we'll do it EIGRP to RIP. How? We'll go again on the VIOS 8, simply exit. Now we will say the router, that router EIGRP 100 redistribute RIP metric. Now, if you will see that as we are redistributing the EIGRP, so you'll see it is asking for the bandwidth. Let's say I'm giving bandwidth. Now it is asking for the delay. So let's say I have given some 100 of delay, and then it is asking me for the reliability. Let's say I'm giving the reliability as 255. Now again it is asking me for the load. So let's say I'm giving some load as 1, and then lastly it's asking for the MTU. So by default I'm giving 1500, but make sure that when you are working in the production environment you must give the accurate matrix, because this is just some test sample to show you. Now once this is done, in this VIOS 9 configurations you will see some external routes which you let me show you. And this is the VIOS 9. So in this VIOS 9, as you can now see that this was the previous output. Now if you will again go show IP route, so you can see that DEX. So this DEX means these are the external routes of EIGRP, and you can now see that the external EIGRP AD value has been assigned here as well. You can see 170 is basically the AD. So according to the external routes, the AD has also been changed here. So this is how basically the redistribution is done. Now if you want to have a look at the command syntax, that what were the commands we used for the redistribution. So on this VIOS 8, we redistribute the RIP from EIGRP and EIGRP from RIP. So for that we have done these set of commands. Let me show you. So the first command was this router RIP, and then we need to redistribute the EIGRP 100 according to the metric. So we did define the metric as hop count, which is 1 as in our scenario. Then we defined this concept here of redistributing EIGRP from RIP. So there we defined the entire metric for this EIGRP. So this is what just basically a simple scenario which we have done of EIGRP from RIP and RIP to EIGRP. Now in the next upcoming part, that as per this pre-constructed topology, so every IP has already been assigned in this topology, and we will see some redistribution. So I'm deleting all these labs as of now because it is of no use to us, and more better clarification we are going to get in this pre-constructed topology, where like there are some EGPs, there are some BGP as well. So we will see as we all the routing part we are going to cover up, and we will see the redistributions as well. So let's try to see all the IP addresses between the devices. So all the devices are already on. So this is VIOS 1. So in this VIOS 1 we'll go enable show IP interface brief. So as you can see on the gig 00 we have used 10.100.200.1. Now if you also want to try and verify is there any routing done, so let's write show IP protocols. So you can see there is no routing done in this environment. So what we will be doing is, so initially as of now we have already constructed assigned the IP addresses here. Now we will be configuring some BGP, OSPF and EIGRP according to the topology here in this redistribution lab. So where we can say that on the router 1, which is your VIOS 1, VIOS 2 and VIOS 3. So here we are going to do some BGP process, and on the VIOS 4, VIOS 5 and also on some VIOS 3 we will be doing some OSPF process, and between the last routers which you can see router 5 and router 6, so there we are going to cover up some EIGRP process. So let's try to get started with basically this entire lab scenario. So as I have already shown you that there is IP constructed on the topology. Now once the IP part is done here, we will be simply doing some routing, and you can also have a look at that configure terminal, and we will say router BGP as this is a part of 100 AS. Then the neighbor we are going to define is 10.100.200.2 because this is the neighbor here, and the remote AS we have is 200 because the neighbor is having the AS as 200 as it's an eBGP. So exit once we are done with the router 1 configurations. Let's minimize this. Let's go to router 2. So on the router 2 you will see that here on this router 2, let me show you show IP interface brief. So you can see on the router 2 that gig 00 and gig 01, there are two interfaces. On 01 we have 10.200.250.1, and on 00 we have 10.100.200.2. So now we will do the same with the VIOS 2 as well. So let's try to verify router BGP 200. As this router is a part of BGP AS 200, so we will have to define two neighbors here. So let's say neighbor, and the first neighbor I will define is 10.100.200.1, and then the remote AS for this neighbor will be your 100, because 200.1 network is basically a part of AS 100. So you can see that the BGP agency has been built up. Then we will say again neighbor, the next neighbor we will define is 10.200.250.2, and the remote AS will be on this particular AS, though we are having is 250 here. So this will be the next neighbor, and we can also advertise the network. Let's say network advertised here. I am gonna advertise 10.100.200.0, and the mask which we have used here is 255.255.255.252, which is your /30. So once this is done, we will simply exit. Now we will go on the router 3 to configure some router OSPF and BGP as well. So on this VIOS 3, let's verify the IP configurations first. Interface, show IP interface brief. So you can see on the gig00, which is a part of BGP domain, and gig01, which is a part of OSPF. So both are having their own IPs, which are given as per the topology. So now on the router 3, first we will configure some router BGP, let's say. So router BGP, and the AS we are having is 250 here. Now we will write neighbor. So who will be our neighbor? 10.100.250.1. So this is our neighbor, and the remote AS this neighbor is having is 200. So once this is done, we will advertise the network 10.200.250.0, and the mask we will be advertising is 255.255.252. Now once this part is done, we'll simply exit here, and we will see that also router OSPF is there. So we'll write router OSPF 1, and on the router OSPF 1 we will define one network which is 16.0.0. So we will say 172.16.0.0, and then we will define the wildcard mask, which is 0.0.0.255, as I have used /24 in the OSPF domain, and then I will define the area as area 0. So once these configurations of router BGP and this router OSPF are done on the router 3, so we will be moving towards your VIOS 4, 5 and 6. So here we are on this VIOS 4. So we can verify the IP, show IP interface brief. So you can see on gig00 we have 1716 network, 16.0.2, and on gig01 we are having some 100.1. Now we'll go and assign some router OSPF process here. So we will say network, I have 172.16.0.0, which is having 0.0.255 and area is 0. Then again I do have one another network which is 172.16.100.0. So these two networks are there which are having the same wildcard mask, and the area is also same. So you can see that it has formed the neighborship with the 16.1 network, which is a part of VIOS 3 here. Now once this is done, we'll move towards the VIOS 5, and then slightly we'll configure our VIOS 6 as well. So here this is our VIOS 5. Let's verify the IP, show IP interface brief. So you can see the IPs 172.16.100.2 on gig00, and on 01 we have 10.20.30. So the gig01 will be a part of EIGRP. So let's say router OSPF first, one, and we will say network. So here we have 172.16.100.0, 0.0.255, and the area is your 0, and exit. So we will wait for the agency to build up, and then we will see some EIGRP configuration. So as you can see, it has built the neighborship, and now we will configure some router EIGRP 100. And let's say the network we will be advertising is 10.20.30.0, and we will define the subnet mask as well, because we have used some /24 here as well. And once this is done, exit. And the same command set configurations we need to done on the router 6 to form the EIGRP agencies. So here we have your VIOS 6 console screen, and on this console screen you can see enable show IP interface brief 10.20.30. So configure terminal, and we will see router EIGRP 100 and we will be advertising the network. So let's say the network will be 10.20.30.0 and 255.255.255.0 and exit. So you can see the dual agency has been built up. Now, as we have completed this entire topology by doing some configurations of BGP, OSPF, and EIGRP. So now if you will go on the router where we have done the routing, so on the router 1 and on the router 2, you will see on the router 1 and on the router 3. Let's verify the routing tables. So let's say on this router 1, we'll go show IP route if I'm gonna. So you can see only the directly connected and locally connected routes are there. But if you will now go and verify the routing table of this VIOS 3. So let's try to verify show IP route. So you can see there is one OSPF route here, right? Now, when we are going to see all these configurations, so we can check it out where there is no BGP route. So just let me check the configurations once again on this VIOS 3. So we have assigned the route to BGP 250. Then we have defined the neighbor 10.100.250.1, which is a part of, which is not basically a part of remote AS 200. So here you can see, guys, we have done one mistake, that the neighbor while I was assigning, which is 10.100.250.1. So this is basically a part of your remote AS where basically we are going to define as 100. So, okay, so now we will go and check one more route we need to define. So let's go and reconfigure the router 3. So let's say we'll write no router BGP 200. So once this is done, we'll again configure router BGP 200 and let's say neighbor. We are gonna say neighbor router BGP 200 BGP AS 250 is already running. Okay, no router BGP 250, and now we'll say router BGP 250, and now we will again see the neighbors. So the neighbor will be 10.200.250.1 and with the remote AS will be for this 250.250.1, not it's 1, it's 2, sorry. So okay, for here we are having 250.1. Yeah, it will be 1 and the remote AS will be 200 here. So once this is done, the next neighbor we will be defining, let's say neighbor. So you can see the agency has been built up and the next neighbor is 100, let's say 10.100.200.1, and we can say that the remote AS will be 100. Now if you will verify, also let's advertise the network 10.100.200.0 and we will write the mask as 255.255.252 and exit. Now if you will go and see the redistribution process on this VIOS 3 here, it's 3 show IP route. So we can now see that some BGP routes are also there, which we have redefined, and some OSPF routes are also there. So once this part is done, basically, guys, now we need to do some redistribution. And before that, let's see some routing table of this. You know, we can say this VIOS 4 as well. So let's go and verify the routing table on this VIOS for show IP route if you will write. So you can see as of now, there are no other external routes which are being configured here. Now we will go on this VIOS 3 configurations and we will do the configurations here. So let's say configure terminal and we will say router OSPF 1. So this is your router OSPF 1 we have defined, and we will say redistribute BGP and the AS which we are having is 250. So once this is done, exit. Now you will verify the routing table of this router 4. So we will see some routes. So you can see some OSPF E2 routes which are coming from 10.100.200 network, right? So now if you will also try to see the routes on this VIOS 5. So let's try to go on VIOS 5 and let's try to verify show IP route. So in this also you can see some OSPF external type 2 routes are also there. So basically you can see that in this OSPF external type 2 we are getting the network for 10.200 network, which is basically a part of your BGP domain. Now again, if you will go back on the router 3 and when you will see the redistribution again, so it will be router BGP 250, and we will say redistribute OSPF. The process ID which we have used was 1 exit. And now if you will go and let's try to verify the routing table on route 2, show IP route. So here you can see some OSPF routes are being learned here. You can see on the router 2, which is basically a part of BGP, but still as we have redistributed the OSPF, so the routes are still there. So you can see 172.16.0 network and 100.0, both of the OSPF networks are there. Let's try to verify the VIOS1 as well. Let's see show IP route. So here also in the VIOS1, you guys can see that both of the routes are there from the OSPF domain. Now, once this part is done, the redistribution on the router 3 between the OSPF and between the, we can say between the BGPs. But now if you will try to ping from the, let's say, let's try to check the connectivity. Are we able to ping it to the OSPF or not? So let's say ping, I'm going to say 172.16.100.2. So we can see the success rate we are getting is 100%. And for better verification, we can trace route. So we can say 172.16.100.2. So this is the last destination. So let's try to trace the route as well. Meanwhile, let me check any queries are there or not on the chat box while we are tracing the routes. So as you can now see guys that the first packet reached on 10.100.200.2, then it will be reaching on the next interface of the autonomous system, which is 250.2. Then now it will reach to the OSPF domain. So as you can now see that we have completely traced the route. So this is how it's going to work. So now configuring the EIGRP part. So let's go and try to do the EIGRP configurations. Now if you will go on the VIOS 5 where we have configured the EIGRP. So on the router EIGRP 5 we will say ping 10.20.30.2. So we can say that the success rate we are getting is 100%. So let's say let's do some redistribution here. So let's say router EIGRP 100. Then we will say redistribute OSPF 1 and the metric as we are redistributing EIGRP. So we'll write the matrix. So let's say 1, 2, 3, 4 and then 1, 2, 5, 5 will be the let's say load. Then lastly we have some load and we have some MTU. So once this redistribution is done, exit. Now also let's try to redistribute router OSPF1, and once this is done, redistribute EIGRP 100 and exit. So simply now that's done. So now if you will go in the router 6, when you will verify the routing table, so you will see, let's try to verify the routing table, show IP route of this VIOS 6. So you can see we are getting some external EIGRP routes, which is coming from some VGP network, and some routes are also coming from your OSPF network. As you can see, these are the part of your OSPF. This is coming from your BGP process. So as we can see that OSPF routes and BGP routes as per the redistribution are all the routes which we are having in this VIOS 6. Now if you will try to ping, let's say 10.100.200.1. So are we able to ping it or not? Because still you can see we are having the route information here, right? So as it is failing, so as we have also the routing entry is also there for the 200 network. So you can see that in the router 6 that we have configured here, so the routing entry is also there, but still it's not showing me any kind of communication. Now for that we'll go on the router 1 and we will verify show IP route. So we can see that in this VIOS 1 we are not getting any information about the EIGRP network. sorry, so we will be like no routes of 10, 20, 30 network of EIGRP in this router 1. Now the thing is the router EIGRP, like the router 6 which is configured with the EIGRP, has learned about the BGP routes. But why didn't the BGP learn about the EIGRP routes? So now to check this, we will go on the router 3 and let's verify some configurations. So on the router 3, and let's say show running config pipe section begin OSPF. So let's see the configuration. Okay, so as you can see that here we are redistributing some routes of BGP 250 and then it's added in the subnet. And on the BGP we have redistributed the OSPF 1 as well, as you can see. So the reason the default behavior, like when we are, guys, there is a reason behind this particular part. That the reason is that whenever we are redistributing the OSPF into BGP, is to only redistribute the OSPF internal routes. Like when you will study in the CCNP NRC trainings, you will find that there are types of routes in OSPF as well, that we have some type 1 and type 2 routes in OSPF. So these routes are basically, these types of routes are pretty much mandatory over the networks, or we can say whenever we are doing these redistributions. So basically to rectify this, we need to go on some configurations on this router 3, and we need to tell this router 3 to externally to accept the external type 2 routes as well. So we'll go on the route OSPF, sorry, not on the OSPF, we'll go on router BGP, and then we will write 250. So once, because we are running 250 AS here, and we will say redistribute OSPF and this process ID 1. Okay, just a second. Redistribute OSPF 1, and then we will say match interval. Now what interval you want to match? So if you're question mark here after interval, you can see some external is there. So let's say external is saying that redistribute OSPF external routes, because those were some type 2 OSPF external routes. So we'll write external, and then if you'll put question mark here, so it is saying that there are two types of routes in OSPF, type 1 and type 2, which I discussed verbally. So let's say external type 1 also I want, and external type 2 route also I want. So once this is rectified, and then simply you are going to exit, and now if you will verify the routing table of the VIOS 1, so you will see that here we are getting the route of EIGRP after rectifying the type 2 route of OSPF into this VIOS 3. So now if you will be trying to ping with VIOS 6 to VIOS 1, so you can now make sure that both the entire basically the communication will be there. So if you will go and try to verify it on VIOS 6 here, so if you will see ping, so you are now getting the 100% read. We can trace the route, let's say 10.100.200.1. So let's try to trace the route, and by tracing the route we will be done with this entire lab which we have done. So basically we have done this lab related to some BGP process, like we have advertised BGP, OSPF and EIGRP simultaneously, this entire topology. So let's try to see the routes as well. So now as you can see here that it is going via some 1020.1, then it reached on 172.1600.1, and now we will also see where it is going to reach next. Then after 101 it went on 16.0.1. Let's try to verify more. Now you can see on the 250 AS of the router, which is your VIOS 3, your packet is there. So now you can see that the entire routes we have traced here. So you can see that 10, 20, 30, the packet reached on 30.1, then it reached on 100.1, then after 0.1, which is the B class OSPF domain, and then lastly on this particular router, which was 200.1. So this is how the redistribution needs to be done on the devices, and this is how we make sure that the IGPs and the BGPs should communicate over the network when we are doing this redistribution. So guys, that is all about this webinar, and if you find it useful, thumbs up, and let's see that anything else we can help it out. So if you have any queries, just feel free to put your queries in the chat box, because that is all for your webinar, guys. I hope you all have a great day and you have amazing learning from this session. So thank you so much, guys, for joining.